Real number system. We know that Q represents a set of rational numbers which can be expressed in the form of P over Q, where PQ belongs to I and Q is not equal to 0. We have also discussed that integers, including positive integers, negative integers, zeros, all kind of fractions, proper fractions, improper fractions, mixed fractions, and decimals, terminating decimals, recurring decimals, can all be expressed in the form of P over Q, where P and Q are integers and Q can never be equal to 0. But now we have another class of numbers which is different than rational numbers, and therefore we can write those as irrational numbers. So Q dash will represent set of irrational numbers, and these are the numbers like plus minus under root 2, plus minus under root 3, plus minus under root 5, and so on. Now if we take account of rational numbers as well, which are integers 0 plus minus 1 plus minus 2 plus minus 3 and so on, include all kind of fractions 1 over 2, these are proper fractions, plus minus 17 over 3 which is improper fraction, plus minus 2 whole 1 over 4, that's mixed fraction, and all other decimals like plus minus 0.314, plus minus 3.3 bar, plus minus 6.67 bar, and combine both rational and irrational numbers to give us a set of real numbers, which is union of rational numbers and irrational numbers. Now this R is called the set of real numbers, and when we define laws, the similar laws which we already defined for rational numbers, this will make a system of numbers which we will call a real number system. Now R is set of real numbers, and following laws govern operations in real number system. As we have defined before, we are going to define first Closure law, with respect to addition. Now these laws are sometimes called properties, so in some books you might see this as a closure property with respect to addition, and in mathematical language we can say that for all means for any AB belonging to R, means for any two real numbers we have A plus B belonging to R, means the sum of two real numbers is another real number. And commutative law, which is again sometimes called commutative property, and we will say, so this is with respect to addition, for all AB belonging to R, means for any two real numbers A plus B is same as B plus A. And third, associative property. Associative property. For associative property we take three real numbers. That's why we're gonna say for all A, B, C belonging to R, A plus B plus C is equal to A plus B plus C. What really these brackets mean that if you take sum of A and B first and then add C to it, or you add B and C first and then add A to the sum of B and C, the result is going to be same. And to give an example, if you have 2, 3, 4, and when we say the sum of last two would be 7, 2 plus 7 would be 9, or the sum of first two, which is 5, 5 plus 4 will be. So you can see that it doesn't matter if you add or if you take the sum of last two and add that sum to the first, or you take the sum of first two and add it to the third, the answer is always going to be same. This is called associative property, and for all x belonging to R means for any real number there is 0 belonging to R. 0 has a very special significance that when added to any other real number it doesn't make any difference. X plus 0 is same as 0 plus x, and it again is x itself. 1 plus 0 is 1, 2 plus 0 is 1. So this 0 is a very special real number and it's called additive identity. Here 0 is called additive identity. And fifth means for all real number, for all x belonging to R, there is minus x belonging to R. Like for every real number there is a number on the other side of the real line. So for if this is 0, for 2 there is minus 2, for 1 there is minus 1, for minus 4 there is plus 1. So for all x belonging to R there is minus x belonging to R, such that when you add both of them minus x, the answer is going to be additive identity. So what is additive identity of plus 2? The additive identity of plus 2 is minus 2. What is additive identity of minus 1 over 5? For additive identity of minus 1 over 5 is plus 1 over 5. You simply change the sign. If it was positive, additive inverse would be negative, and if the number was negative, the additive inverse would carry the positive sign. So these are 5 properties with respect to addition, and same 5 properties. Now properties with respect to multiplication. Multiplication is a binary operation which operates on 2 real numbers, and we are going to define same those properties. Closure law with respect to multiplication. So we say for all A, B belonging to R, A times B belongs to R, means that product of any 2 real numbers is always a real number and it is contained in that set. So number 2, this is commutative law. Commutative law with respect to multiplication. So if this is with respect to multiplication, we can say for all A, B belonging to R, A times B is same as B times A. Like 3 times 7 is 21 and 7 times 3 is 21, so that doesn't make any difference. Again, associative law. Associative law. For all A, B, C belonging to R, we have A times BC is equal to A B times C. This is same like if you take the product of B and C first and then multiply the product with A, or you take the product of AB first and then numbers within this brackets always are multiplied first. And number 4, multiplicative identity. For all x belonging to R, we have 1 belonging to R. Again, 1 is a very special number such that 1 when multiplied with x from left side or multiplied with x from right side, that doesn't make any difference, and that's again equal to x. Here 1 is called multiplicative identity. And number 5, multiplicative inverse. For all x belonging to R means for any real number we have x inverse. This is how it gets denoted, which is equal to reciprocal of the given real number, such that x times 1 over x or 1 over x times x, the answer is always multiplicative identity. So what is multiplicative inverse of 3 over 2? The multiplicative inverse of 3 over 2 will be 2 over 3, and that will give us the answer 1. So 2 by 3 is multiplicative inverse of 3 over 2. Similarly, what is multiplicative inverse of 2? That is 1 over 2. What is multiplicative inverse of minus 3? That will be minus 1 over 3. So you simply reciprocate the number and you'll get the multiplicative inverse. Now there are some other properties of real numbers, which first of them we are going to say is called trichotomy property. And what this means is that any two real number can only have one out of three possible relations. For all x, y belonging to R, either x is less than y, number 1, or x is equal to y, or x is greater than y. So at one given time, any two real numbers can only have one relation. This means that x is less than y. This means that x is equal to y. This means that x is greater than y. So if 2 and 3, which one of these is the relation? So tri means 3. So out of 3, the only one is true. So the first one would be true. The 2 is less than 3. Therefore, the second will not hold, third will not hold. So at one given time, there is only one of these that will hold. So this is a trichotomy property. And now there are distributive properties. Distributive properties. So addition, multiplication is distributive over addition. For all x, y, z belonging to R, x times y plus z is equal to, we can multiply x with y and x with z. This will give us x times y plus x times z. This is called left-hand distributive property because we are multiplying x from the left side. If we were to multiply x from the right side, we can say that x plus y times z is equal to, same dot z will be distributed over addition of, and this with y. So we will have x times z plus y times z. And now a reflexive property, now we are talking, these are the properties with respect to equality. And this means that x is equal to x, means that x is related to itself. X is equal to itself. This is called reflexive. And transitive property. Now these reflexive, transitive properties are with respect to the equality. Transitive, if x is equal to y and y is equal to z, then x is equal to z. This is called transitive property. And then there are cancellation properties, both with respect to addition and multiplication. For all x, y, z belonging to R, if x plus z is equal to y plus z, this means we can write x equal to y. So z from the right side can get cancelled. Or x z is equal to yz. This means x is equal to y. Again, this is cancellation law with respect to addition, cancellation with respect to addition, and this is with respect to multiplication. And there are properties with respect to inequalities, properties with respect to inequality. These are the properties we have all discussed earlier in the section of rational numbers, but two of these properties are particularly important, and I would only mention both. If x is less than y, then minus x is greater than minus y. So whenever you multiply any negative number on both sides, the inequality sign will change. This is of particular importance. And number two, the very important property is, if x is less than y, then 1 over x is greater than 1 over y.